In this lecture we are going to talk about recursion. Recursion is a process where a function being defined is applied within its own definition. In other words, recursion is a process where function call itself. This kind of function is called recursive function. Recursive function can be defined by two properties: a terminating scenario that does not use recursion to produce an answer, also known as a base case, and a recursive step which defines a function call to itself. Here we have an example of recursive function which calculates a factorial for a given integer number. You can see that this function has a termination scenario, so-called base case, where it returns 1 if the input parameter is equal to 1. Also, this function has a recursive step where the same function is called, but this time with different parameter. In order to understand the recursion, we need to perceive the concept of the call stack. A call stack is a memory location that stores information about the active functions of a computer program. This memory location is managed as a standard stack data structure where elements can be added and removed only at the top of the stack. Each new function call is added at the top of the call stack. The function call located at the call stack is called a stack frame. It contains necessary information of the function to be executed. Stack frame information can vary depending on programming language, but usually it contains information on local variables and operations, return address, and function parameters. It is important to have in mind that only the top stack frame is accessible for CPU. The lower stack frame is not accessible until the upper stack frame is not popped out of the call stack. The stack frame is popped out of the call stack when the function finishes its work. For example, let's say function 2 has finished and then it is popped out of the call stack. After that, new stack frame is accessible for execution. Let's go back to our example of recursive function factorial. On the right side of this slide, you can see a simplified view of a call stack. Assume that the program is running. The first function, which is the main, is already added to the call stack, and we can execute the code within this function. We have found the function println, which is responsible for printing the result. So now we must add it to the call stack. Note that main function is now inaccessible since at the top of the call stack we have the function println. We have the factorial function as a parameter in the println function. In order to print the result, first we need to execute the factorial. And we need to add it into the call stack. Now we are able to execute the code within the factorial. As you can see from the call stack, the number parameter is equal to 5. Therefore, if condition is not satisfied, we need to go to the else branch. Here we have the product operation where one variable is equal to 5 and the other is another call to function factorial. That means we need to add this function to the call stack. Note that we made the call of the same function, but in the call stack it is considered as a different function with its own stack frame. It means that we need to execute the same code but with different parameter. Since in recursive step of our function we pass number of -1, in the next stack frame we have number equal to 4. You can see that the top stack frame has the aforementioned parameter. We need to go to the else branch again. And here we have another factorial function call. Again, the new stack frame is pushed at the top of the call stack. This time the number parameter is equal to 3. The workflow is identical to previous cases, therefore let's look at execution without any commands. Now, at this point we have reached our base case. of the recursive function. It means we can return 1 and finish this function call. Remember, when the function is finished, it returns the result and the corresponding stack frame is popped out of the call stack. The stack frame contains the return address of the function, which means that the program knows where the result of this function call should be used. In a recursive function, the result of a previous function call is used at the lower stack frame of the same function. After a factorial with parameter 1 was popped out, the top stack frame became factorial with parameter 2. It also means that the number value of 1 is used to the current stack frame as a result of a previous factorial call. The result of this function call now be calculated and it is equal to 2. We can return the result and the corresponding stack frame must be popped out of the call stack. As in previous case, we use this result at the current stack frame. The number value at this stack frame is equal to 3 and the result of the previous function call is equal to 2. The product of both is equal to 6. Again, we can return and pop out a stack frame. We use the result for calculation at the new top stack frame and the result is equal to 24. Next, we return and pop out, then execute the product operation, which gives the answer as equal to 120. It was the last recursive factorial function call. It means that the result is equal to 120 and it is the final result of the factorial function. This result is used at the new top stack frame. At this stack frame we have the function printline. Now it is the time to finish the printing. This function prints our factorial result and the stack frame of printline can be popped out of the call stack. Now we can finish our program. As we pop out the last stack frame, which is the main function, the program ends its execution. The key point of this lecture would be the following. Recursion is a process where a function being defined is applied within its own definition. A recursive function consists of two major parts, a base case, where termination scenario is defined, and a recursive step. Each function call in a running computer program is managed by the call stack. A call stack operates as a standard stack, where each element can be added and removed only at the top of the stack. A function call added to the stack is called a stack frame. A stack frame consists of major information required for execution of the code within the function, for example, local variables and operations, return address, parameters, etc. Recursive functions may significantly simplify the program code. The main disadvantage of recursion is that it requires additional memory for storing the stack frames in a call stack. The call stack size is usually limited, so large amount of function calls may cause the stack overflow error. Adding function call information into the call stack also takes additional time. The function call time overhead may be quite significant in some programming languages. Thank you for your attention.